Well, given that, that's why I went to get back to this frame drag stuff, because time has been shown to be a non-linear dimension. That's been proven. And furthermore, since you can go to different parts of time space and find elasticity or compression, that would suggest that the harvesting of this energy would be different in different locations of those density, because the time elongation of compression would be different.
Well, but in this theory, those things are not expressed that way. In fact, it's deliberately avoided to express things that way. Because you can't really distort the dimensions of time and space because they're metrical dimensions. But let's get a little more. Okay, we have dimensions that are called quantitative dimensions, and we have dimensions that are called metrical dimensions. I wasn't going to read this. The dimensions of space and time are dimensions of measurement. The measure of how far, the measure of how long, space and time are metrical dimensions. These conceptual dimensions are not those of a concrete physical or electrical reality, but are rather a sort of mental process. So the ideas of distorted time or space basically just says that you're building clocks that are distorted and you're building rulers that are distorted. In electrical engineering, it's considered a lab. That's why I'm making sure to reinforce these concepts, because this is very important in electrical engineering, otherwise you won't get it.
You're saying that relativity, general relativity, doesn't hold that?
Yeah. Basically, it's just a way to explain away electricity and eliminate it. I in fact think it was a conspiracy. Well, if Heaviside painted his fingernails pink and slept on concrete blocks, maybe not everyone went along with it. But we already heard what Tesla had to say about it. I mean, the whole beginning of the book was filled with horrible Michael Savage stories, and everybody all disgruntled. So maybe I'm not just making this up. Because if you want to understand Tesla, you better get all this stuff out of your mind, or you're not going to get one iota of understanding of how Tesla works. You'll be permanently blocked from understanding it. That's my theory of why there's the theory of relativity. But we're not here to talk about the theory of relativity. We're here to get away from it. We have an electrified wire. The wire is not carrying the electricity, but it's this induction in the space surrounding the wire that represents the electricity. The radial lines are what are called the electrostatic, or as Faraday called them, the dielectric lines of force. The circumferential lines are the magnetic lines of force. And at every point in space, they exist at right angles to each other. So one is basically the antitheses or the denial of the other. This would be the repeating theme that we will see through this whole lecture, is the conjugate relationship between magnetism and dielectricity. Now, at every point at which these lines cross, where the radial lines cross the circumferential lines, this represents electromagnetic energy, and it is flowing into or out of the paper parallel to the axis of the wire. At that particular crossing point, we call that the unit of the Planck. And in Einstein or quantum ideas, it's called a photon. Go to the next one. Okay, now when we have a system of conductors which bounds the electric field, then it becomes trapped by the wires. That's why there's always more than one wire used in transmission systems to bound the ether between the wires. So now we have the radial lines of force are tending to pull the wires towards each other mechanically by shortening. The magnetic lines of force, the circumferential lines of force, are tending to fill the space between the wires and push them apart mechanically. At a certain stress point of the dielectric, which we would call the voltage, and a certain stress point of the magnetic, which we would call the amperage, the two forces counterbalance each other, and no force appears on the wire whatsoever, and this is called the natural impedance of the system, where the two energies are balanced out. We're going to get much deeper into this electric field. So if we're looking down the power lines, then this is the two wires, and we'll get deeper into this later as we go down. So here we have the crossing points. Okay, that's the electromagnetism. Then we have the circumferential lines of force, which is the magnetism, which is rotary in character, and is basically dimensionally considered velocity. Now we have the dielectric lines of force, which are everywhere at right angles by definition, being the antitheses of the magnetic. So basically, one becomes the gradient lines for the other. One defines the other in a conjugate or mirror sense. Now these lines of force move along in this direction. Now the magnetic lines of force must surround in closed loops the electrical or electrified objects. They can never end in space. In other words, this is just because it's gone off the paper. The dielectric lines of force must always terminate into what we will call counter space, or what J.J. Thomson called intermolecular dimensions. So by more conventional theory, we can say that this line of force is stuck to an electron on this wire, and this line of force is stuck to a proton in that wire. That would be your more physiochemical representation, but no one really knows what's going on inside these wires. And the electricity all moves this way down the paper at the speed of light. The ratio of these two quantities must always equal the speed of light. This was Maxwell's fantastic discovery that not only is the speed of light a velocity, but is also the constant ratio between the amount of electrostatic or dielectric and magnetic energies in the system. And the impedance of this type of configuration always tends to be, again, a numerical value based on the geometry. But the speed of light has this duality, and this is where the confusions of Einstein and relativity and everybody emerged from, was this duality of the electric field that was discovered by Maxwell. So I'm going to read some more Maxwell. We're going through his cells. Okay, J.J. Thomson, as well as Heaviside, altered the Faraday-Maxwell concept such that now a electrostatic field constituted the tubes of force, and that a magnetic field was a secondary effect, or Faraday referred to as the dielectric field. J.J. Thomson used the term Faraday tube to describe a unit line of electric force. Let's go to J.J. Thomson's diagrams. Okay, here, the back. He's showing the attractive force exerted by dielectric lines of force between two bodies. Now, Thomson felt, unlike Faraday felt that the lines were magnetic, but Heaviside and Thomson felt that the dielectric were the primary and the magnetism was just that circling around the dielectric. It's kind of like a chicken or egg consideration that's never really been fully resolved because the ether has no tangible physical dimensions. Okay, now what's happening is these lines of force tending to be contractive pull the plus and minus together. And this basically is a representation of the process of attraction. Now we go to the next one, we have the process of repulsion. So in the process of repulsion, we don't have lines of force pushing the two objects apart. What it is the lines of force now have to terminate on more remote surfaces of molecular dimensions. And what it does is it pulls them away rather than pushes them away. So the repulsive process is not really a pushing apart, it's a pulling apart. And there's a void here in the middle of the absence of electrification rather than a concentration of it. So Tesla also regards the ether as a gas and succeeds to produce these ultrafine high-speed particles in his vacuum tubes. Now, I've duplicated this in experiment. He claims velocity is 50 times that of light. Tesla's tubes gave the ether the properties of mechanical force against ponderable matter. I'll describe an experiment I did where I took these special Tesla type of currents that we'll get into later, why they're different, and energized light bulbs with them. Well, the light bulbs don't light up like normal on this because this is not normal electricity. So this kind of solar system or galaxy starts to appear inside the bulb with little suns and comets and stars, and gradually becomes cumulative like these power line oscillations. And what happens in this process is that actually, even though that the bulb has a vacuum or partial vacuum in it, is the glass when heated starts to push out. Something is pushing the glass out. So what has been done is the ether now has been solidified into something that can exhibit physical force against matter. So what happens is this entity inside the bulb produces so much impact and heat on the glass that when it melts, it'll melt a hole in the bulb. Now, you would think when a hole is melted in the bulb that the air would rush in and wreck the partial vacuum and the bulb would cease to work. Well, it's the exact opposite. What happens is this purple ether comes shooting out of the hole like a little air compressed jet and hisses, and the vacuum in the bulb becomes stronger. So this completely turns the concepts of what's inside empty light bulbs inside out. Steinmetz regarded the existence of the ether as a reality, but changed horses when the concept of the ether was eliminated by the Einstein concept of distorted measurement of what is called relativity. A natural philosopher by the name of Lamore, at this point, says we should not be tempted towards a simple group of relations, such as Maxwell had tried to create, which have been found to define the activity of the ether by treating them as mechanical of concealed structure in that medium. We should rather rest satisfied with having attained their exact dynamical relations and not be into describing a physical, because they're not physical. Okay. Now, it looks like I've run out of material here for some reason. There we go on the sheet. Okay, so I think we need to start going through these. It was very difficult to get all this together in time, and most of it got like lost or shuffled, or this talk came hot out of the oven. So let's go through here, and then I'll start talking about. Okay, well, now we're going to get into a more practical situation. So here we have a long-distance telephone line, a basic, simple reality. We're going to focus in on that. So we're going to look a little closer. I'm doing measurements on it with my car. You can't see the antennas. I think you can kind of see them up in the front. They're about 10 feet high. The car has equipment in it to give it the ability to sense the way insects do with their antennas through the electrostatic field. That special equipment inside the car right now, determining what kind of forces are around various power lines and rocks and those type of things. It's part of my research. Okay, we'll take another shot. Okay, now we're into each individual transmission pair. Okay, we'll focus in tighter. So this is what we're dealing with. Okay, now we're going to go to a graphical. This is what we have. There's the two wires. Okay, and we have an impulse started at the sending end, going to the receiving end of the wires, and then the diagrams are the conversions of the ether in the space between the wires into what are called electrical constants of inductance and capacitance and resistance and conductance. And then the field diagram between those two wires, which we go back to the two wires, then we go back to the field diagram. Okay, now those are the two wires cut sideways, and these are the two wires going end to end. So let's go to the next slide. Okay, now we're going to start to take this space apart between the wires. So we're going to start with the quantity of total electrification, which we're going to call the Planck. Okay, and this quantity is going to be considered undivided. That's the basic electricity between the wires. Okay, and this consists of two parts. One is called the total magnetization in Webers, and that's the Greek letter phi, and the Greek letter psi is the total dielectrification between the wires in coulombs. So let's go back to the space between the wires so we can show where these things exist. This here in this diagram is the dielectrification, and we're symbolizing the totality of the dielectrification. In other words, the total number of lines of force in our system, which is the span between two utility poles, okay, with the Greek letter psi. The magnetic forces, which form the circumferential circles, we're taking the total quantity of that between the two poles, and we're going to call that the Greek letter phi. And then the point at which these unite, the net sum of all those, we're going to call Q, or the total electrification in the system. So let's go back to our equations. So we have the total electrification, and then we have the magnetization and the dielectrification, and these are named after Planck, Weber, and Coulomb. So let's look at them. There's Max Planck. These are all very famous people. A lot of them you don't even hear about. Let's go to Weber. These are the guys that basically created our technology of today. And then Coulomb. Okay, let's go to the next. Now we're going to start to get this stuff broken down. So we get our basic relationships. So if we take the ratio of the total electrification to the total dielectrification, then that gives us the magnetism in Webers. If we take the total electrification, the ratio of that to the total magnetization, then obviously that gives us the total dielectrification. And the electrification is the unqualified product of magnetism and dielectricity. In other words, these are the two aspects of a dielectricity. This is the outer space aspect of dielectricity, and this is the inner space aspect of dielectricity. Okay, let's go on. That means multiplication, but not generalized, not qualified multiplication. It can be any type of product.
If I were to take a macro view of this concept, I see this. I've been looking at density patterns in the ether. Is that how you're interpreting?
Exactly.
Okay, so like flux patterns.
Right.
There's a waveform actually fluctuating through this ether.
Exactly. Yeah, that's where I'm developing these ideas now. So, right. Now this is what's called an electromagnetic configuration. But not, as we'll see later, not all configurations are electromagnetic. Now in this case, this is the cross product. But as we'll find later, the multiplication is more general than that. That's basically the whole crux of this talk, is to come up with the non-electromagnetic, or what we call the Tesla component. So let's keep going then. Okay, so this is we're basically just saying here that magnetism and dielectricity are the two components of electricity. Steinmetz eliminated the use of the word electric field because it's not correct. He called it the dielectric field in Faraday's terminology. Everybody has agreed upon the magnetic. In Steinmetz's electrical theory, electricity has to be the product of these two quantities. If it is not, if it's just one or the other, it's not electricity. So a charged capacitor is not electricity. Okay, a trapped magnetic field in a motor winding is not electricity. It's only when these two things cooperate interdimensionally with a relationship where the energy of one is exchanged into the energy of the other through a cyclic process do we have the appearance of electricity. Okay, let's go on. Okay, so now when we start to deal with this stuff in space, we start to get into some complexities, and that's what I'm trying to present here. So if we take the total magnetic densities, okay, and on a per area basis, in other words, we have lines per square centimeter. Let's call this the density of magnetic induction, which would be in Webers per centimeter squared, in square centimeters. Okay, obviously we can do the same thing for the dielectric condition. So if we have a cube sitting in there, in between the wires, there's going to be a certain number of lines of force going through this 1 square centimeter clear plastic cube that the waves just go right through. The wires are just the boundary. The electricity is flowing in this dielectric between the wires. This was Maxwell's profound discovery. Electricity does not flow in conductors. In fact, actually, in the days of Franklin, metals were called non-electrics because they destroyed the electric field. The complete opposite conception of what's been put in our minds today. Okay, we have an interesting situation. Now, if we try to take this back to the electrification, we have area squared, and this is going to pop up again and again, is now we have the dimensions of space to the 4th power, which a physicist would be tempted to call 4-dimensional space, but we're going to modify that concept because that leads errors into the mind state. So we're going to work around that, and I'll get into that a little later. So basically, these are just our basic tenets of what's to follow. What I'm trying to do is so that everybody knows what these terms that we bandy about are, like volts, amps, ohms, watts, coulombs. Everybody uses these words in electricity, but nobody really knows what their definition is. I could ask everybody in this room what a volt is, and I would get a different answer, and chances are almost everyone would be wrong. But we're going to learn what a volt is. So let's move on. Okay, so if we take the quantity of electrification and we vary that with respect to time, in other words, it gets stronger or weaker or moves somehow so that in time its quantity changes, we call that work or energy in joules. So in other words, energy does not have a primary existence in this electrical theory. Energy is actually a derivative. So we have all of our derivatives of electric fields here. So if we have the magnetism, the total magnetization, and we vary that with respect to time by strengthening or weakening the magnetic field, that gives us E, electromotive force in volts. So that when someone asks you what a volt is the rate at which magnetism is produced or consumed in an electrical system. That is the definition of a volt. Okay, now, if we take the total quantity of dielectrification, okay, and vary that with respect to time, in other words, we either produce or consume a dielectric field, and it changes with respect to time, we call that I, and that's called the magnemotive force in amperes. Okay, now if we take the quantity of electricity and vary it to the time squared, or if we take the product of these two, which gives us this, in other words, this times this gives us this, we call that power P, or activity. P is the power activity in watts. So then we'll look at the people whose names we're using. So there's Joule, Volta, Ampere, and Watt. These were the people that conceived these ideas that we're talking about now. Okay, we'll go on to the next. Okay, now what we're going to do is we're going to get into the proportionality of the situation. So if we have a magnetic field and we have a current which is associated with it, we take the proportionality between the two, that gives us L, or what we call the magnetic inductance. And that's given in henries. So the inductance of an electrical system is the magnetism compared to how much current is required to produce it. So if I can produce 100 units of magnetism for 1 unit of current compared to 1 unit of magnetism for 1 unit of current, the 100 units of magnetism for 1 unit of current would have 100 times the inductance of the other situation. So it's a basic proportionality. Now the same thing exists with the dielectric field. If there's a dielectric field and there's a voltage, or in this case a potential associated with it, then for every quantity of dielectric field, there has to be a certain amount of electromotive force that gives rise to that dielectric field. And we call this proportionality C, or the dielectric capacity, in farads. So we have henries and farads. This is called inductance, and this is called capacitance. These are all things I think a lot of people have heard about, but never really got a definition of what they meant. These are basically geometric proportions determined by the configuration of the so-called conductors and insulators, and do not change with the actual quantity involved. It's merely the proportionalities of the quantities and their inner workings. Now, if we take the ratio of the electromotive force to the magnemotive force or current, we call that Z, or impedance, and this is given in ohms. And conversely, if we look at it from the dielectric point of view, if we take the magnemotive force or current and take the proportionality of that to the amount of voltage or EMF or potential in the system, that gives us Y, which is called the admittance. This was a word developed by Steinmetz. This was a word developed by Heaviside to describe these things. And that's given in what are called Siemens. Then we'll look at the people that are attributed to the development of this. Henry was an American, by the way. He was called the American Faraday. But he being an American, the British made sure that he was kind of left out of the story, so you don't hear about his experiments. But without him, Morse couldn't have developed the telegraph, because Morse was a painter and an artist. He was not an electrical engineer, and he needed Henry to wind all of his coils. Okay, then we have Faraday. Faraday is basically the granddaddy of all of this. They call him the Columbus of electricity. It was his experiments that started the electrical age. He used no mathematics. It was all done with pieces of wood and bottles and things like that. No big giant Livermore labs, none of these things. Yet his work stands to this day. Okay, we'll go on. Then Ohm, he was the one that found the proportions between these constants that we saw earlier, like the amount of electricity to the amount of magnetism, or the amount of volts to amps. They didn't have a lot of these words back then. Made it hard for them to work on. There was no volt or amp or ohm. But Ohm was the one that worked these relationships and produced them for the first time. Then we go to Siemens. Siemens was successfully created one of the world's first long-distance telegraph lines that went all the way from Russia to India. And massive quantities of scientific information were gleaned out of this, and this is basically what started Oliver Heaviside, because he was the first mathematician to analyze the telegraph and telephone line, which created our modern engineering mathematics. Okay, let's keep going. Okay, now we have a situation that's a little different. These are where our energy anomalies occur, is in these type of conditions. Okay, if we have the inductance of a system and we vary that with respect to time, in other words, if I have a electromagnet and the core is moving so that like in a motor, so that the inductance is varying with respect to time, we call that R, or resistance, okay, which can be either given in henries per second, but customarily we call that an ohm because it's in the same dimensions as impedance. And then conversely, if we vary the capacitance with respect to time, we call that G, or conductance, which in America they use Ohm's name backwards, or Mo, which is inconvenient, so I stuck with the Siemens because that letter S is actually needed later down the line. So it turns out to be in a generalized electrical system, this component represents the destruction of energy, and this component represents the creation of energy in an electrical system, whether it either be synthesized, or it converts from electricity to mechanical, or it converts from mechanical to electricity. Then these are the ways that it goes back and forth. So your light bulbs, your space heaters, your motors, your computers, all that type of stuff involve these relationships so that the electricity can find its way out of the system and appear as heat or light, or in some cases be dimensionally dematerialized and disappear completely from the system, which does happen. Okay, and then if we take the product of these two terms, they give us the dimensions of time squared. So if we take the square root of the inductance times the capacitance, that is how we derive what's called the frequency of oscillation. In other words, there has to be a time rate of energy exchange between the magnetic and dielectric field as they constantly dump from one into the other. We're going to get into the mechanism of that a little further down the line here. Basically, what I have determined in my research and with this mathematics and experiments and other people's work is that energy can be taken apart or put back together. So we have outer space, or we have inner space. So it's plus and minus in either it's in an outside space, like the space of real estate in acres, or it could be an inner space, such as in between the molecules and electrons inside a transistor. So inside the transistor, we have a condition of inner space, or what Rudolf Steiner called counter space. That's the term that I use for this. It's called counter space. There's space and counter space. But in order to make it truly a duality, we call one outer space, which would be the space outside the wires, and then we have the inner space, which would be the space inside the wires. We have the exact same condition in the ether. Okay, and if I take space, I can take space such as I can represent that blackboard by a certain number of square centimeters, and that is in the dimensions of outer or space. But if I take a ruler and I look at the space in between the lines, I call that inner space or counter space. So space is measured in centimeters. In this case, in other words, it's to the positive exponent, but counter space is measured in per centimeters, in other words, to the negative exponent. So this is a very important consideration. Now we go to the next one. There's two systems of logarithms that are in general use. The upper system of logarithms, which gives us our normal trigonometric functions of sines and cosines, and also can give us our hyperbolic sines and hyperbolic cosines. And it's based on a Newtonian mathematical operation where you go through this process, and that is the way you express your so-called trigonometric relationships. It makes the equations work. In other words, I can have 2 pi radians, and that tells me that that's one circle, but it has to be in this basic mathematical form. But there's another one that's called the golden ratio. Now, what's interesting about the golden ratio, that is this particular expression. Now, in the golden ratio, we find that if we have the golden ratio, which would say the letter A, just to represent that specific ratio as a quantity A, if I subtract it from 1, I get the same answer as if I take that A and I raise it to the negative 1 power. So if we go back, the golden ratio, ultimately, this is one of my projects I'm working on now that I have no more equipment. I only can get involved in mathematics. Is to come up with a system of logarithms that utilizes the golden ratio to attempt to bring these two dimensional representations together. Now, what Steinmetz did in his study of power lines is in order to eliminate having to use these multiple differential equations, go from space to time and express space-time, what he did is he measured the length of all the power lines in light seconds. And by making his measurements in light seconds, instead of meters or centimeters or cycles per second or these things, what happened is then all of a sudden, these two dimensional relationships unified, and And Steinmetz was able to calculate and visualize and explain electric waves traveling in these phone lines and power lines that no one had even knew existed. Most of this stuff will not even appear on the voltmeters in a lot of systems, and there's no way to measure it, because they're existing in these various time frames, going backwards and forwards in spaces. And Steinmetz came up with a much more advanced theory of electricity that unfortunately was never allowed to complete. But he started on it, and it's something to work with. So let's keep going here. Where do we leave off? Okay, now we're going to go into this actual capacitance and inductance. So the phenomena of capacitance is a type of electrical energy storage in the form of a field in an enclosed space. This is what we've already seen in our ether diagrams. This space is typically bounded by two parallel metallic plates or two metallic foils on an intervening insulator or dielectric. A nearly infinite variety of more complex structures can exhibit capacity as long as there is a difference in electric potential or electric potential exists between various areas of the structure. The oscillating coil, or Tesla coil, for an oscillating coil, represents one possibility as to a capacitor of more complex form, and this is what we're getting into. Tesla. Okay, let's keep going. Okay, the perception of capacitance as used today is wholly inadequate for the proper understanding of this effect. All the lines of magnetic force are closed upon themselves. All lines of dielectric force terminate on conductors, but may form closed loops in electromagnetic radiation. These represent the basic laws of lines of force. It can be seen from these laws that any line of force cannot just end in space. We've pretty much seen this graphically already, so let's continue. Faraday felt strongly that action at a distance is not possible through empty space, or in other words, matter cannot act where it is not. He considered space pervaded with these lines of force. Almost everyone is familiar with the patterns formed by iron filings around magnets. These filings act as numerous tiny compasses and orientate themselves along the lines of force existing around the poles of a magnet. We saw this in the picture further back. Experiment has indicated that a magnetic field does possess a fibrous construction. By passing a coil of wire through a strong magnetic field and listening to the coil output in a pair of headphones, the experimenter will notice the scraping noise, in other words, the sound of the lines of force breaking on the conductors. J.J. Thomson performed further experiments involving ionization of gases that indicate the field is not continuous, but it's a fibrous structure. He presents this in his book, Electricity and Matter, in 1906. This is where he developed the concept of the electron. Okay, we'll keep going. Consider the space between poles of a magnet or a capacitor as full lines of electric force. We've already seen the pictures. These lines of force act as a quantity of stretched and mutually repellent springs. Anyone who has pushed together the like poles of two magnets has felt this springy mass. Okay, we've seen the figures. We've gone through all that. This is what we're talking about here. Is this diagram of attraction, and then the next diagram of repulsion. Okay, in figure 1, the lines of force are more dense along AB between the poles, and that more lines on A are facing B than are projecting outwards to infinity. So in other words, the lines are in between the two objects. Considering the effects of the lines of force on A, these lines are in a state of tension and pull on A. Because more are pulling on A towards B than those pulling on A away from B, we have what appears to be the phenomena of physical attraction. Now we observe from figure 1, notice how that the poles are like rather than unlike. This is the second diagram, where all lines pull A away from B. This is the phenomena of physical repulsion. The lines of force can be more clearly understood by representation of it as a tube of force or a long, thin cylinder. Maxwell presented the idea that the tension of a tube of force is representative of electric force in volts per inch. And in addition to this tension, there is a medium through which these tubes pass. There exists a hydrostatic pressure against this media, what's called the ether. The value of this pressure is 1/2 the product of the dielectric and magnetic density, which are these terms we've already encountered. Then there is a pressure at right angles to the electric tubes of force. if through the growth of a field the tubes of force spread sideways or in width, the broadside drag through the medium represents the magnetic reaction to the growth and intensity of an electric current. However, if a tube of force is caused to move endwise, it will glide through the medium with little or no drag as if little surface is offered. This is the opposite type of wave to the electromagnetic wave. The first one, sideways movement of the lines of force, is like moving a sail through the atmosphere. There must be a reaction. So if the dielectric lines of force represent the sail, if it's moving sideways through the space, then the air movement represents the magnetic reaction, and the energy of the entire system then can be called electromagnetic in analogy. But if the lines of force, if the sail is made to move sideways, there is no drag through the air, there is no velocity of light, there is no magnetic field, and now we have the world of Nikola Tesla. This is the type of transmission he was using. Is the ether more dense in one part of the solar system than the other? The question has always been asked, is the ether carried with the Earth, or does the Earth move through the ether? And then the thing is that the ether being physical at all, there's no way to pinpoint it. All of these people, as you find in Whitaker's book, for the hundreds and hundreds of pages, came up with all these models of the ether that couldn't possibly work.
Michaels and Morley showed that too.
Right. Everybody came up, that's why this guy Moore stated that let's just drop trying to say what the ether is, because we have all the interrelations handed to us through observation of electric phenomena. As Heaviside said, why should I not eat my dinner? Because I don't understand how I digest it. Now you have to remember, when you get out in outer space, the rules seem to change quite a bit, but this stuff they don't tell you that. For example, you can't see the sun or the stars in outer space. You can see the moon, you can see your hand, you can see the spaceship, you can see rocks, you can see the planets, but you can't see the sun and you can't see the stars. So there's something about, there's a primary light and a secondary light, and then you have to figure what kind of voltage gradients exist between Earth and the sun when Tesla says the sun is charged with 2 billion volts of electricity. The whole of the solar system, that's the only way to explain how a planet like Pluto, because a large number of planets are lining up right now. And what this does is this causes solar flares. Okay, the physicists, you tell that to the physicist, particularly an astronomer, they'll be twitching on the floor, puking their lunch up. But nevertheless, this is well known by all RCA engineers, and it doesn't matter what physicists think, because all RCA cares about is money. And if the transmitters don't work, then the money gets cut off. So what RCA found is that planetary alignments influence the solar flares and the electrical conditions of space and cause these massive changes in radio propagation that go beyond anything you can explain with aurora borealis, or because I studied this stuff for a long time at Sonoma State with all the RCA equipment, and there's something much deeper going on here. If you look at the planets as elements of a capacitor, and there's electrostatic lines of force between all of these planets, then it seems to make sense that if they move into configuration, the lines of force will be able to join up better. And it's also a condition of capacitance, as we'll get into some of it here, is if you take two objects which have an electrostatic field between them, and the more you try to separate them, because they mechanically want to pull each other together, the more you try to separate them, the higher the voltage has to raise in order to keep the quantity of energy constant, according to the law of conservation of energy. And the voltage will continue to raise. This is how lightning is formed, until eventually nothing can withstand that stress, and it blasts. So this is going on in outer space, and somehow, as a friend of mine said, NASA is abbreviation for never a straight answer.
But your whole idea of the planets lining up,
Right.
well,
It's not my idea. It's kind of the idea. I'm not really creating any of this. I'm just taking all the pieces and putting them together. Just kind of, they told me in high school that I was retarded. So I'm just kind of, a homeless person that just takes books and pastes pages on, other pieces of paper in the public library.
I was accused of this. It's okay. But
Let me get back to this because I don't want to lose track of our concept. So we're talking about lines of force and capacitance. So much of the mystery surrounding the workings of capacitance can be cleared by close examination of inductance and how it gives rise to dielectric phenomena. So basically what I'm saying is our knowledge of magnetism and inductance is farther than the knowledge of the dielectric And the capacitance, because the physicists say there is no dielectric and there is no capacitance, that it's electrons. And it's action at a distance. There's no lines of force in between. It's electrons and there's no electricity. It's matter. But this is a grave mistake, and this is what we're going to climb out of. Okay? Inductance represents energy storage into space as a magnetic field. So if we look at all those lines of force around the magnet, that represents the storage of energy. In other words, there exists there in that field the force keeping it alive, stored electrical energy, just like a bottle in that magnetic field. The lines of force orientate themselves, as we've seen, in closed loops surrounding the axis of current flow, which is basically a shadow of the magnetism. It's the magnetism scraping on the wire. That's what we call current flow. The larger the space between this current and its images and reflections, that, in other words, the wire on the other side, the more energy that can be stored in the resulting field. So, in other words, the bigger the space between the wires, the more space we have, the more outer space we have, the more magnetism we can hold in that bottle. It just makes absolute physical sense. Let's continue. The process of pushing these lines or loops outward, causing them to stretch, represents storing energy as in a rubber band. The given current strength will hold a loop of force at a given distance from a conductor passing current, hence no energy movement. The situation stabilizes itself. If the flow of current increases, the energy absorbed by the field, I can't read it. Can someone read that for me? Or can
Absorbed by the field
as the loops are then pushed outwards at a corresponding velocity. Because the energy is in motion, an electromotive force must now accompany the current flow in order to represent power. The magnitude of this electromotive force exactly corresponds to the velocity of the field. As we've seen, a change in magnetic field with respect to time is voltage or electromotive force. So as long as there's change in the magnetic field, there must be an electromotive force. A model would be, is if you're flying down the road at a constant velocity in your car, you feel no motion. You're not being pushed forwards or backwards. But as soon as that velocity varies with respect to time, then all of a sudden there's an inertial response where you either are pulled forwards or pulled backwards. This variation in velocity, the rate of change of velocity, where velocity is analogous to magnetism through the swirling of the ether, the electromotive force results as a reaction to any type of change in that system, just as inertia. In fact, we call inductance in electronics electrical inertia. So in the motion, an EMF must accompany the current flow in order for it to represent power. The magnitude of this course, we'll go on through that. If the current ceases changing in magnitude, thereby becoming constant, no EMF accompanies it, as no power is being absorbed. However, if this current is decreased and represents then a negative velocity of the field as the loops contract, because the EMF corresponds exactly to velocity, it reverses polarity and thereby reverses power, so it now moves out of the field and into the current. Since no power is required to maintain a field, only current, the static or stationary field represents stored energy. Okay, we'll move to the next page. Many interesting features of inductance manifest themselves in the two limiting cases of trapping the energy or releasing it instantly. We call these the limits of zero infinity. In other words, time equals zero, or time is instantaneous. In other words, there's no time to grab onto. When it is switched off, the inductance drains its energy into the resistance that converts it into a form of heat. We will assume a perfect conductor that has no resistance. In other words, we have a coil or a system that's cooled to absolute zero, let's say. If we remove the current supply by shorting the terminals of the inductor, we've isolated it without interrupting any current. Since the collapse of the field produces EMF, this EMF will tend to manifest. However, a short circuit will not allow an EMF to develop across it, as it has no resistance by definition. No EMF can combine with current to form power. Therefore, the energy will remain in the field. It will be trapped. It will be closed. The door will be closed by the wire tying the two ends of the coil together and forming a complete circuitous loop for the magnetism to be trapped inside. The experiment of this is you take a piece of lead cooled to absolute zero and drop it in the liquid helium that's cooling it to absolute zero on a magnet, is it will float on the magnetic lines of force because now it's become a perfect conductor, which is not true. It's a perfect obstructor, like Heaviside says. The magnetism cannot get into the counterspatial or interdimensional material of the metals because of the absolute zero and cause electron flow. So the so-called conductor will float on the magnetism because there can't be any change in the energy balance. So you have like a type of magnetic shock absorber or spring. It can't fall down because the magnetism will hold it up or exactly what we're talking about here. Any attempt to collapse the field increases the current, which pushes it right back out. This is one form of storage of energy. Okay, now we're going to go on. Okay, now we're going back to our fields. This is where our energy actions are, is in this field. Let's keep going. Going back to our fields again. So this is the space we're in. Okay, now, very interesting and dangerous phenomena manifest themselves. This is particularly when you're working on DC ships. This is something you really have to watch out for. Manifests itself when the current path is interrupted. In other words, if you break the circuit wide open, like one of those vacuum switches tried to do on the substation disconnects. In this case, the resistance is best represented by its inverse conductance. The conductance is then zero. Because the current vanishes instantly, the field collapses at the velocity approaching that of light, theoretically. That still hasn't been measured. As EMF is directly related to velocity of flux, it tends towards infinity. Very powerful effects are produced because the field is attempting to maintain current by producing whatever electromotive force is required. That's what starts feeding these flames on the switches. If a considerable amount of energy exists, say several kilowatt hours, that's what you use in your house in one day, or 250 kilowatts for a lightning stroke. A lightning stroke has 250 kilowatt hours, or 250 units of energy we're dealing with here. The ensuing discharge can produce most profound effects and completely destroy adequately protected apparatus. So if, let's say, I have a 50 horsepower DC motor and has these giant inductance coils in it to create magnetism. Now, if I go into the contactor box, I find this big resistor in there. And what it's designed to do is when that contactor opens up and tries to disconnect the inductance from the rest of the bounding electrical system, the collapse of the magnetic field will generate whatever voltage is necessary to keep jumping across those contacts, and it will leap out and kill you. So they put these drain resistors inside the motor starting boxes to absorb that blast so the magnetism can release itself in a sane rate. So this is something in DC you have to deal with this situation. And what will happen is if you break the circuit instantly, we'll get it, but if you can't do it, it gets into another process inside the windings that will prevent it from going to infinity. And this is what we're going to go into next. The magnetism, the energy has to go somewhere and finds another route. So let's keep going. So now we have another form of energy storage to try to absorb this up, and that's the capacitance. Okay, through the rapid discharge of the inductance, a new force field appears that reduces the rate of inductive electromotive force formation. This field is also represented by lines of force, but these are of a different nature than those of magnetism. These lines of force are not a manifestation of current flow, but of an electric compression or tension. This tension is termed voltage or potential difference, and these are our dielectric lines of force. So the magnetism will produce an electromotive force to try to maintain the current flow, but this electromotive force will then create a dielectric field, and this ultimately limits the situation so it doesn't go to a trillion volts. Usually in a big motor, it'll limit off at about 10 or 15,000 volts, but usually it'll blow holes in the windings. So let's keep going. Unlike magnetism, the energy is forced or compressed inwards rather than outwards. In other words, we're going into a counterspatial relationship. The electric lines of force push inwards into internal space and along axis, rather than push outwards broadside to the axis as in a magnetic field. Because the lines are mutually repellent, certain amounts of broadside or transverse motion can be expected, but the phenomena is basically longitudinal. This is, we're getting into Tesla's world now. This gives rise to an interesting paradox that will be noticed with capacity. This is that the smaller the space bounded by the conducting structures, in other words, the closer the wires are together, or the closer the plates of the capacitor, the more energy that can be stored. So it's defying our concept of a bottle holding energy. In other words, in this case now, the smaller the bounding structure, the more dielectricity will hold because it's being held in counter space. So the electric field, let's go back to the electric field diagram. Okay, so these magnetic motions or velocities, okay, and these dielectrics are referred to more as torque or compression. The magnetic lines of force exist in outer space. The dielectric lines of force exist in inner space or counter space. So the electric field in between transmission lines or telephone lines or coaxial cables or any of these things represent the storage of energy in two different aspects of the dimension of space. So in other words, we could say in physics terms that there's two dimensions of space that we're dealing with here. Outer space and inner space. And these have the independent ability to store electricity, which is in there in actuality because it will either shock you or it will burn something out or it'll explode or it'll light up a light bulb or whatever. It's there. Okay, let's go back. So the smaller the space bounded by the conducting structures, the more energy that can be stored. This is the exact opposite of magnetism. With magnetism, the units of volume of energy can be thought of working in parallel, but the units, volumes of energy and associated with dielectricity can be thought of working in series. So magnetism tends to deal more with the square area type of space storage, where the dielectricity is more the space in between the lines on the ruler, which can keep getting smaller and smaller, where this one keeps getting bigger and bigger. Okay, let's keep going. With inductance, the reaction to change of field is the production of voltage or electromotive force. The current or magnemotive force is what we're talking about current. We're also speaking of magnemotive force. We have to go back to our original relationship. Like I can't jump so far so fast. The current is proportionate to the field strength only and not the velocity of the field. With capacity, the field is produced not by current, but voltage. This voltage must be accompanied by a current in order for power to exist. The reaction of capacitance to change of applied force then is the production of current. So where the magnetism's reaction was voltage or electromotive force, the capacitor's reaction is current or magnemotive force. So the inductance reaction of electromotive force creates a potential to charge the capacitance, but the capacitance reaction creates magnemotive force, which tends to feed the inductance. So we have energy trapped in a self-denying situation where one storage is the antitheses of the other, and the energy can never stay put. It has to constantly go back and forth. That's how we get our frequency. We go back to the time equation. This is what determines the frequency, because it has to go back and forth. It has nowhere to go, and it can't stay put. So let's see, I left off. The current is directly proportional to the velocity of the field strength, just like with magnetism. When voltage increases, a reaction current flows into the capacitance and thereby energy accumulates. If voltage does not change, no current flow, and then the capacitance stores the energy which is produced in the field. So we store the energy in the coil by tying the two leads together, but we store the energy in the capacitor by taking the two leads apart. So then if we look at coil and capacitor together, one is closed and the other is open, and we can see how this denial process starts this exchange. It's like an antithesis that can't get out of its loop, and it has to occur at a definite frequency.
So the frequency is the third dimension.
Well, no, frequency is a time dimension where the inductance and the capacitance are geometrical proportions, spatial geometrical proportions. They have no real dimensions in their own being. They're more, well, I'll get into that later, what the dimensions of these things are. Okay, so where did I leave off here now? If the voltage decreases, then the reaction current reverses and energy flows out of the dielectric field. As the voltage is withdrawn, the compression within the bounded space is relieved. When energy is fully dissipated, all of the lines of force vanish. So what we've seen is when we discharge the inductance by breaking the circuit, in order to keep the situation in the realms of reality and not infinity, the dielectric field had to take all this up. So in these paragraphs, we've seen how energy is basically moved out of the magnetic field and into the dielectric field, and in the reverse situation can bring it right back. Let's go further on. Because the power supply which provides the charging voltage has internal conductance, after it is switched off, the current leaking through the conductance drains the dielectric energy and converts it to heat. This is just like the resistance did in the inductance coil. We will assume perfect capacitance having no leakage conductance. In other words, in the inductor, we had perfect conductivity or zero resistance, and in this case, we have zero conductance. So we have perfect insulators. The open circuit the terminal is a capacitor. No path for current flow exists by definition of an open circuit. If the field tends to expand, it will tend towards the production of current. However, an open circuit will not allow the flow of current as it has zero conductance. Any attempt towards field expansion raises the voltage, which then pushes the field back inward, so it's trapped. Therefore, the energy remains stored in the field. This energy can be drawn for use at any time. It's another form of energy storage, which exists in a conjugate relation with the storage of magnetic energy. So we keep going. Phenomena of enormous magnitude manifest themselves when the criteria for voltage or potential difference is instantly discharged. This is how Tesla managed to create the special type of oscillating and impulse currents that he used in his technology. We'll see about these later. The effect is analogous with the open circuit of inductive current. Because the forcing voltage is instantly withdrawn, the field explodes against the bounding conductors with a velocity that may exceed light. Because the current is directly related to the velocity of the field, it jumps to infinity in its attempt to produce a finite voltage across zero resistance. If considerable energy has resided in the dielectric force field, again, let's say several kilowatt hours, like in the household daily use, that quantity of energy, the resulting explosion has almost inconceivable violence and can vaporize conductors of substantial thickness instantly. Dielectric discharges of great speed and energy represent one of the most unpleasant experiences the electrical engineer encounters in practice. When you're dealing with these giant phase-advancing capacitor banks in these substations that connect the grid together, is if those things stay charged, is if you don't drain them through a resistor, but you try to short that thing out, the blast will just basically blow your eardrums right out and blind you. But the energy of a capacitor is nearly instantaneous, and it tends to be more of a retarded type of phenomena. This one doesn't slowly build up. This one slowly builds down. Okay, so let's go on. No, back one.
Next one.
The powerful currents produced by this sudden expansion of the dielectric field naturally gives rise to magnetic energy. The inertia of the magnetic field limits the rise of current to a realistic value. The capacitance dumps all of its energy back into the magnetic field, and the whole process starts all over again. The inverse of the product of the magnetic storage capacity, which we call inductance, and the dielectric storage capacity, which we call capacitance, represents the frequency or pitch. In other words, the rate at which this energy interchange occurs. This pitch may or may not contain overtones or harmonics, depending upon the extent of the conductors bounding the energy. So this basically, this part here on the ether is complete. We'll have you answer. Let's see, I got enough time. I'll have you ask questions on this now, if anyone has any questions. No questions?
I'll offer a comment.
Okay.
When we were at all the power supplies for some of the particle developments that we were playing with years ago, this idea of giant capacitor banks discharging essentially in real time was quite well demonstrated.
Yeah.
We blew things up all the time. We got very principle, so I can justify that.
Okay. Well, I can't believe nobody has any questions on something this, everyone understands everything I'm saying?
Oh, that's a good thing.
How many people understand 10% of what I'm saying or more? Okay. I think everybody's getting something out of it, though.
Yes.
Okay. Well, as long as I'm not putting everybody to
Well,
sleep.
let me throw one question out since we're talking about this concept. What if you had the potential for time phase shift, even very slightly, you would then perturb dramatically, I would think, the energy quotient potential just given reference point in this model. Possibly?
Yeah, that's what, remember when I went back to the, I don't know if we can go back there or not, but when I showed the dimensions of resistance were inductance varying with respect to time, and then I showed the dimensions of conductance were capacitance varying with respect to time, that's the time shift. And what that does is then energy starts to go sideways into a dimensional relationship where it's no longer energy. Its pieces may still be there, but it's no longer, the pieces no longer make the pie, which we call energy. Instead, we just have the can of cherries and we have the bag of flour. They're all still there. They haven't gone anywhere. You can take energy, okay? Now, according to Heaviside's law of the continuity of energy, that energy that exists in this capacitor coil can vanish as long as it exists in another time. But that still meets the requirement for the law of continuity of energy. So this is basically how we get energy synthesized in electrical systems is by moving it around in time. That's where an alternating current phase is always the number one word in everything we're dealing with, is where are you at in the cycle? And you can build electrical machines to do this. I've seen them where energy will go into a generator, okay, and the generator will have no load connected to it, okay, and you can have a kilowatt meter, okay, sitting on the input of this generator, not an amp meter or voltmeter, won't give you the real energy flow. It'll give you a false reading. But if you have a power factor corrected kilowatt meter, or I haven't done it with a kilowatt hour meter, that would have been the proper way to do it. Energy will go into this rotating machine, which varies with reluctance with respect to time, such as an Alexanderson alternator, and the energy will vanish. You'll be yanking power and paying for it from the utility company to make this thing spin, and the energy is not heating the bearings up. It's not making windage. It's not coming out of the shaft, out of the wires, or the energy is simply taken apart by causing this time shift in the magnetic cycle in the 60-cycle alternating current field.